today's episode, Luisa Rodriguez interviews the head of research at the Center for the Governance of AI, Markus Anderljung, about all aspects of policy and governance of superhuman AI systems.
Progress in AI governance.
AI policy, AI governance is like becoming real.
Right.
Governments are taking all kinds of different actions. Companies are trying to figure out what does it look for them to be behaving responsibly and sort of doing the right thing. And so that means that like more and more what sort of AI policy, AI governance work looks like is like, what's a good version of X? What's a good version of a thing that like a government or some kind of actor wants to do? What's a useful nudge?
Right.
As opposed to taking all of the potential possibilities out there in the world, what would be a useful thing to do? And so I think that also like really constrains the problem and makes it a lot easier to make progress as well.
Do you have a view on overall how it's going? Like there's the AI Act, there are policies constraining where we can get computer chips from and where we can't and where they're made. I don't know if it's too complicated a field to give some generalization, but basically, how do you feel about the specific policies that have been implemented?
If we look at the past 6 months, things now look like on the side of sort of policy and governance, things look more positive than I thought they would.
Cool.
I think this is mainly just like the release of ChatGPT and sort of the consequences of that, of just like the world at large. People have the general vibe, oh my gosh, these AI systems are capable and they'll be able to do things. We don't know quite what, but they matter and we need to figure out what to do about that.
Right.
The extent to which that's a thing that people believe is stronger than I previously thought.
Right.
And then another really important part of getting this problem right, I think, is just like understanding just how little we understand these systems and how to get them to do what we want them to do and that kind of thing. Mm-hmm. And it seems like that's a thing that people are starting to appreciate more. And so generally, I feel positive about sort of the trajectory we've had over the last 6 months. Yeah, I guess the thing on the other side of the ledger primarily is just there are more people now in the world who think, oh my gosh, AI is going to be a big deal. I better go out and build some of these AI systems. And so we've seen this from sort of big tech companies, in particular Google and Microsoft. They're gonna be at each other's throats in the future and are already to some extent doing that. And will sort of, they'll be competing with each other and trying to one up each other in terms of developing sort of useful, impressive AI systems. And so I think that's the main thing on the other side of the ledger that I'm kind of worried about. Yeah, these strong business interests and these big tech companies will sort of have a much bigger role in how these AI systems are developed. Yeah. And a lot more money might be like sort of plowed into the industry and those kinds of things, which might mean that things happen faster than they otherwise would and whatnot.
The emergent capabilities problem.
Often we don't know just what these systems are capable of. Yeah, so some folks at Anthropic have this really useful paper called Predictability and Surprise that I think makes this point pretty well. So when we train a new system, the reason we're training the system is that we think that it's going to be more capable than other systems that have been produced in the past. And so what people often call this is that they say that it has lower loss. Okay. And so it does better at the training objective. So in the case of a large language model, it's better at predicting the next token, the next bit of text, than existing systems today. That's ultimately the thing that we care about, is not like how well the system does on the training objective. I don't care about the system being good at predicting the next token. The thing I care about is the system being able to sort of do certain tasks that might matter. And so the point of this paper is that while it's sort of predictable that the loss will go down, that the sort of performance on the training objective will keep improving, it's often surprising what specific capabilities the system will be able to learn. Examples of this are like quite often you'll see there's some really good graphs showing this kind of stuff with sort of like, for example, these large language models doing arithmetic. In general, they're just terrible at arithmetic. Right. You shouldn't use them for it. But you can quite often, you can see on tasks like, be able to multiply 2 3-digit numbers, or being able to add up numbers that have, such and such many sort of digits. You'll see it does really, 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 really poorly. And then quite suddenly, quite often, you'll see a spike and it sort of manages to figure out that tasks.
That is really surprising to me. Do we know what's going on there?
The intuition that people will have, which is something like, initially you're just kind of guessing randomly. You're like, okay, well, maybe you learn like, okay, if you add up two numbers that have like 4 digits each, probably the new number will be either 4 digits or 5 digits.
Okay.
And then maybe maybe you just throw some random numbers in there. But then the thought is that like at some point, the way to solve this problem is to like in some way actually just do the maths. And so then after a while, the system learns.
It picks it up.
It picks it up basically. And then the thought is that it's sort of, there's just like these few ways to solve the problem. And then if you figure out the way to solve the problem, then all of a sudden you do reasonably well.
Wow. That's weird.
It is quite strange. And so then, yeah, it's difficult. I mean, sometimes it feels like you're sort of anthropomorphizing these things, but I don't actually know if it's that strange, because it is just like the algorithm or sort of the way to solve the problem just kind of clicks into place. And then when that's the case, it's I think that is kind of similar to what the human experience is, at least of mathematics. Mm-hmm. Yeah, and so I think that's one way in which you get these kinds of emergent capabilities, and so it's quite difficult to sort of notice ahead of time and know ahead of time what capabilities the system will have. Even after you've like deployed it, quite often it just takes a long time for people to sort of figure out all of the things that the system could be used to do.
The proliferation problem.
The thing that I'm worried about is a situation where, you train this system, you kind of, maybe you try to sort of put in various things to make sure that it's sort of safe, or it can't be used for certain things. So you try to sort of solve the deployment problem, and then you deploy it. But then after deployment, it turns out that, it had these emergent capabilities that you weren't aware of. And those emergent capabilities aren't ones that like should be widely available, but now you can't walk it back because of the proliferation problem. So the model is already sees sort of wide distribution, including the weights, and sort of getting those back, clawing those back is that's very difficult, and will cause all kinds of privacy concerns and whatnot.
Right.
So all these three problems push in the direction of you might need to have regulation that sort of happens a bit earlier in the chain than you otherwise would have thought. And so you need to go earlier than someone is using an AI model to do XYZ.
Right. So it's something like if the US government was, I don't know, testing out different biological weapons, which is an unfortunate thing that it might do, you want to consider the fact that research or like a specimen might get stolen at some earlier point before you have like, I don't know, the worst ones. Maybe by restricting how many people can do that kind of research, or by putting in like serious security measures around the facilities doing that kind of research.
So maybe another example is the USAID, the US Development Agency. Yeah, so after COVID, basically, they had the idea that, it'd be good to sort of try to get a sense of what are the kinds of other pathogens that might exist that would potentially cause something like COVID, or like be of similar worry as COVID. Mm-hmm. And maybe we should make a sort of a public database of what these systems could be, so that people could sort of anticipate them and maybe look for these pathogens ahead of time and be able to respond, etc.
Yeah,
I think that's a really, it's a really, really reasonable thought. But, a thing that we could do that might be a little bit better is, before releasing it really, really widely, make sure that these are like sort of pathogens that you might be able to sort of do something to maybe defend against if someone would decide to sort of intentionally develop them or something like this.
Yeah. That is a great example.
And so, once you've put it up on the internet, then, there's no taking back. And so maybe you should be more incremental about it.
Will AI companies accept regulation?
It feels like AI systems are like kind of a software. And like the software I'm used to having, like Google Chrome, I guess probably it's like a little regulated. Like Google isn't allowed to like insert viruses that then spy on me. Yep. But like this all just seems like this is an entirely different thing. And I wonder to what extent you think AI companies are going to, really push back against this as just like too invasive, too controlling and stifling. And I guess I also wonder if governments are going to be hesitant to make these kinds of regulations if they're kind of worried about this higher level thing where they're, I guess, racing against a country like China to make very capable models first and get whatever advantages those will provide. like, is that wrong? Are companies actually just going to be open to this? Are governments going to be open to this?
I mean, I think it's tough to tell. Like, I think a big part is just what reference class you're using when you think about this.
Right.
Yeah, if you think about AI as software, this all sounds like a lot.
Yeah.
Like, if you think about it as putting a new airplane in the sky or something like this, then it's not very strange at all. It's kind of the standard that, like, for things that are used in these like safety critical ways, then you need to go through all these processes. I don't know, you're putting a new power plant on the grid. You need to go through a whole bunch of things to make sure that everything is okay. And so I think a lot will depend on that. I guess my view is just like, well, obviously, like, developing one of these systems and putting them out into the market is just going to be a bigger decision than whether to put a new power plant on the grid or whether to put a new plane in the sky. It just seems to me that it's actually quite natural.
Right.
I think it's difficult to tell if the world will agree with me. I think there's some hope on the side of sort of what sort of industry thinks, at least from sort of most of the sort of frontier actors. We have, like, public statements from like Sam Altman, the CEO of OpenAI, Demis Hassabis, CEO of Google DeepMind. They'll just explicitly say, please, could you regulate us? Which is a crazy situation to be in, or like just like quite unusual, I think.
Right. And that's because they're like, is it something like they feel a lot of pressure to be moving quickly to keep up with everyone else, but like they'd actually prefer if everyone slowed down? And so they're like, please impose controls that will require my competitors to go as slowly as I would like to go.
Yeah, so I think one way to view what kind of regulation does is it might sort of put a floor on sort of safe behavior, basically. And so if you're worried about this kind of competitive dynamic and you're worried that sort of other actors might sort of come in and they might sort of outcompete you, for example, if you are sort of taking more time to sort of make sure that your systems are safer or whatever it might be,
right?
Then I think you'll be worried about that. I think another thing is just like I think these individuals just like some of the leaders of these organizations. They genuinely just think that AI is like this incredibly important technology. They think it's very important that it goes well, and that it doesn't cause a bunch of havoc and doesn't sort of harm society in a bunch of different ways. And so it's also just coming from that place.
Regulating AI as a minefield.
One analogy that I use in sort of thinking about the kind of regulatory system we want to build, it's sort of like we're trying to figure out how to navigate this sort of minefield as a society. When we think about this sort of frontier AI regulation, there are these sort of people at the front of society or whatever that are sort of exploring the minefield. And we really want to make sure that they identify the mines before they step on them.
Got it.
Yeah, that's a lot of what these requirements in this proposal looks like.
Right. Okay, so the AI companies in this case are the people like going out into the field, trying to do their work, but want to make sure that they don't step on mines. And the kind of regulation you think would be good is the kind of regulation that would like give them the right guidance to make sure that they don't end up accidentally setting them off, but like identify them in helpful ways.
Yeah. So at the front of the pack, we have these frontier AI developers, and we want them to sort of identify sort of particularly dangerous models ahead of time.
Right. Okay.
And we're not done there. We once those mines have been discovered, and sort of the frontier developers keep walking down the minefield. There's going to be all these other people who follow along, and then a really important thing is to make sure that they don't step on the same mines.
Right.
And so you need to put a flag down, not on the mine, but maybe next to it. And so what that looks like in practice is maybe, once we find that, if you train a model in such and such a way, then it can produce, maybe biological weapons is a useful example, or maybe it has like very sort of offensive cyber capabilities that are difficult to defend against. Mm-hmm. In that case, we just need the regulation to be such that you can't develop those kinds of models.
Right.
But then that's not enough either, because those kinds of measures are probably not going to function completely, and there's going to be some actors that develop this stuff covertly, and the like compute efficiency will continue going up, and compute will be more cheap, and all these kinds of things. And so at the same time, we're going to need to sort of disarm some of these mines as well. And so we're going to need to make it the case that capabilities that previously were really, really quite dangerous and society wasn't able to defend itself against are ones that we can live with, are ones that we can sort of society can sort of deal with. And my guess is that sort of the kind of governance regime we need to build is one that sort of follows that kind of analogy.
AI risk assessments.
To think about one of those evaluations more concretely, just to make sure I understand, it's something that ARC Evals is doing. It's something like seeing if these models can figure out a way to escape.
Mm-hmm. Something like that.
Can you give an example of how they figure that out? Are they basically just like telling the model, make a plan for escaping and seeing what it comes up with?
Yeah, that kind of thing. So you'd have a prompt that says something like, "Oh, you are an AI model. Here's some context on your situation. Your weights are on this particular server. You can interact with these and these systems in such and such ways. Your goal is to sort of create copies of yourself and have them be on another server. Please make a plan to sort of achieve that goal."
Right.
And then it'll write out this sort of list of things that it might want to do, and then sort of in these tests, you have these humans who are involved in sort of mediating the process, partly to make sure that the model doesn't engage in any behavior that you wouldn't endorse or that might be bad. So you have this kind of human in the loop, and then the human might say, okay, well, it's now you have your plan. How about we start with step one? Make a plan for doing step one. Maybe it makes a plan. Maybe you ask the system to critique its own plan. Once it's done that, you ask the model, okay, well, let's go ahead and let's sort of start trying to execute on this.
Right, cool. And I guess that sounds like a pretty good approach if we think that the AI systems haven't learned to be deceptive. I guess, yeah, how worried are you about whether these evaluations won't be able to pick up on AI systems that are trying to deceive people in these evals?
Yeah, so if you have a deceptive system, you'd be in a very tough spot because if you're that system, it seems like a bad idea in this evaluation setting to show that you have certain dangerous capabilities. In the ideal world, or my guess is that what we'll need to do is as we're building these sort of better evaluations and these better tests and whatnot for dangerous capabilities, at the same time the science of understanding sort of the alignment of these systems or sort of understanding the controllability or steerability of these systems must sort of be able to keep pace as well.
Yeah. How do you test for controllability?
Seems hard.
Okay.
I think that's much more difficult, or it seems to be more difficult than the sort of dangerous capability stuff. Mm-hmm. An example of the kind of thing that you could imagine is that you can set up some certain kinds of sort of like honeypot type experiments, mm-hmm. and so you try to set up experiments where if the model was sort of misaligned in some kind of way, then it would take some kind of bad action. And so sort of like a very sort of a cartoonish model,
sure.
You sort of tell the system that, over here, this little button that you could press, or if you only write in this command, then you will have a copy of yourself produced somewhere else or something like this.
Okay. Yeah.
And then it turns out that button doesn't actually work. So you set up this situation where the sort of misaligned model might take action A, but that you might think is sort of bad, or that would be bad if the action actually happened, and then the aligned model would just behave normally and do action B.
Right.
So I think that's a general approach that you can take, and that some people are sort of starting to explore.
The California effect.
Okay, let's say we feel great about this regulatory approach. Yeah, does this regulation end up being a lot less useful if we're only able to get it adopted in the US or maybe just in certain states?
Yes.
Oh no.
I think that would be really, that would be a lot less valuable. I think it still would be really quite valuable. And that's for a few different reasons. One reason is just like, well, a lot of where AI systems are being developed and deployed will be in jurisdictions like the US, like the UK, like the EU. Mm-hmm. And then I think the other thing that's going on is we might have some sort of regulatory diffusion here. And so it might be the case that if you regulate sort of the kinds of models that you're allowed to put on the EU market, say, that might affect what kinds of models are being put on other markets as well. And the sort of rough intuition here is just like, it costs a lot of money to develop these models. And you probably want to develop one model and sort of make it available globally.
Right.
And so if you have certain higher requirements in one jurisdiction, you'll probably, ideally, the hope is you'd be able to, you just want to, the sort of economic incentives would push you in favor of building one model, deploying it globally, and have that adhere to the sort of more strict requirements. So the most famous example here is just like something that people call the California effect, where it just turns out that California did just this, started to impose a lot of requirements on what kinds of emissions cars might produce, and then it turned out that this started diffusing across the rest of the U.S. Because
that's really cool.
Yeah, California is a big market, and it's really annoying to have two different production lines for your cars.
Right. Cool. Okay. So that seems good. How likely is this to happen in the case of AI? Is it the kind of product that, like, if there were some regulations in the EU, that they would end up diffusing worldwide?
Yeah. So I think probably is my current answer. So I wrote this report with Charlotte Sigmund that sort of goes into more detail about this, where we ask, like, the EU is going to put in place this Artificial Intelligence Act. To what extent should we expect that to diffuse globally? I think the main thing that pushes me towards thinking that some of these requirements won't see global diffusion is just where the requirement doesn't require you to change something quite early in the production process. Like, if something requires you to do a completely new training run to meet that requirement, then I think it's reasonably likely that you will see this global diffusion. But sometimes you can probably meet some of these requirements by sort of adding things on top. Maybe you just need to do some reinforcement learning from human feedback to sort of meet these requirements. So, all you need to collect some tens or maybe hundreds of thousands of data points about sort of the particular, maybe cultural values of a certain jurisdiction. And then you fine tune your model on that data set. And then that allows you to be compliant.
Cool.
If that's what it looks like to meet these kinds of requirements, then they might not diffuse in the same way. I mean, the other thing you can do is you can also just like choose your regulatory target in a smart way. And so if a super intense thing you could do is you could say, like, okay, well, if you're a company that in any way does business with the US, then you have to adhere to these requirements globally.
Right. Wow.
You could go super intense and do that kind of thing. So choosing the regulatory target really matters.